Hi everyone. So today I would like to talk a little bit about my new prototype of a no solder, no spot weld enclosure for power walls. I have some time ago made these enclosures for 18650 cells, so no soldering would be required in various sizes, but the price works out quite high, so I want to make something that is a lot cheaper to be used for, you know, home RV power. So I have here 5-slot enclosures that will hold 10 cells, and the idea is to use a single cell per fuse per 2 cells, and they would interconnect to form you know, as large group of parallel cells as you need. I made a couple bus bars like these out of just maybe 1 mil copper sheet, just for this demonstration, but I will be assembling one and putting up a fuse, so we'll see how that goes. The tabs I'm gonna use are from my original design. These ones has a low set foam which acts as a spring, but as it's a low set, it doesn't wear out that quick, and should be good for 10 years maybe. So basic concept is quite simple. You just insert those inside like this. Don't know if you can see it, and then bend over the leftover tab. So that's one side with a foam in it, and then the other side is just a plain copper tin plated tab that goes into the next one. And already I made a wee mistake, so just get this out. Now we need to put nuts first, because the tab blocks the nut entry hole. So let me just grab some nuts and get them placed inside. Originally it was a M5, but it doesn't need to be M5 for this application. I think M4 is plenty. So and it's designed for square nuts, but you know, the ordinary ones will work fine as well. So it's gonna be a long video, I think. So let me just get those installed. So depending on you know, how this goes, I might as well, I mean, if there is a, you know, large number of people that are interested in this concept and design, I might go Kickstarter, and so I can make them, you know, as cheap as possible. So everyone can buy, you know, as many as they need and don't break the bank. And that would require, you know, injection molding, and then some dies for tabs to be made. So you know, to bring the cost down, because at the moment they are 3D printed. I have a couple printers running, you know, printing my my main products for the bikes. So it's occupied, right? And then grab some. Right, and then we go and insert the ones into the middle one. So that goes here. It's a bit awkward to put the hexagonal nuts inside because it's designed for square nuts, but it's gonna be fine. For demonstration purposes, it's gonna be just fine. So the initial, there's a initial work, but it doesn't require to have soldering skills or a spot welder. So just like Legos, just a screwdriver, couple simple tools that most people have around the house. Sometimes 10 and right. Okay, so we have some, let me check, nuts inserted. But if this will grow into something bigger than 3D printing, there will be plastic inserts, instead of nuts, inserted by heat. So you only would need to bolt your tabs, and that would be all. And I won't do the full next one. I'll just do one cell just for you to show. Just twists and it's going the wrong way. There we go. Last one. I'm not very good at making videos, I'm more of a technical person. Yeah. So now we're gonna fill these with tabs. Right. Okay. There we go. I mean, you can reuse them. You can. Originally I went with nickel plating, but it made the tabs brittle. So I then, just went with the tin plating, which is basically done on all your ring and spade and other terminals. Nissan Leaf battery has a tin plated bus bars. So you can go wrong with that. Easy as that. Let me just get them all in place. So you see there's no soldering iron, although I have one, you know, just in case I will need on this build. Alright, let me just fold them over, simple as that. There we go. So that's 10 cell 5 slot bank. Okay, this is done, and I need another one, another set of tabs. Just grab some. Okay, now that goes like that. So that's one. That is two. That's fine, yeah. Okay. Now, as I don't have new cells, so I'll be using some of the cells I've used for testing my original kit. So these are Sony US BTC 5A. They're most, I think, powerful. And I will be mixing them so we can have a fire. Those are 3 from Makita cordless drill, and those are LG ones. So I will need 1, 2, 3, 4, 5, 6, 12 cells. That's 6 and 6, 12 cells. And I will be dressing them up. Well, at least some of them. Don't have enough heat shrink. So basically, for this design to work, the cells has to be, you know, with a PVC shrink wrap, or if you don't want that, at least at the top, they should have some PVC left, because there is a PVC gasket underneath that separates, you know, the positive from the negative. And by inserting the cells, it's important because there is some friction and it just might short. So I'll just get a couple done, so it's all, you know, it's all nice and safe. Just basically for testing, so, you know. I'll get those ones done as well. Maybe a bit too long. Yeah, I'll just trim those. Just like that. know the state of charge of each cell, so there might be some current flowing through the tabs, you know. So we'll see. We'll see how that works out. I think I need to redo those. Don't have. Got them open. That one is fine, I think. Yeah, that one's fine. Okay. I'll trim some of those. And for even more safety, I like to use those, I don't know, I mean, they're probably Garolite, Garolite, what do you call them? Gaskets, just to insulate, you know, the negative from the positive even more, you know, so it's, that's just like, you know, for insertion. Nothing else. Okay, so we have something here. We have like triple layer insulation. We have a inner gasket, and you have a PVC heat shrink on top, and then Garolite on the top. And it's also recommended, you know, even if you use plastic cell holders, you know, it's a good safety measure for making them, you know, safe. The power bank application is not that demanding, you know, the loads are quite small per cell, and there's no vibrations. You know, usually they're in the house, so no moisture. Just trying to get this done as quick as I can, so we don't waste time on, you know, simple stuff that you all know. Okay, now I will get the check them out if they're still alive. Okay, no. I'll just put it here. I think the other camera will pick it up. Okay, so this is dead. This is no good. That one. This is good. This is good. 4.16. This is the new ones. 4.16. Yes, same. 6. That's here. Okay. And the rest of them. 3, 7, 3, 8, and 4, 1, 7. Okay, so those are at the same voltage. And I need another one. What do we have? I have some badly soldered LG cells. I'll just use that. That's gonna be fine. Just the voltage. Yeah. That's gonna be fine for this demonstration. Not yet. Interesting. And it's all will light up. Okay. I'll just start. Oh, another one. I would suggest using some. That's too thick, but you can use like 10 mil Kapton tape for like doing bundles of cells. Let me just. Those scissors are good for anything. Right. So I would just. Make them into sort of battery clips, you know, like a gun clip, just like that. Positive. It's not pretty, you know, just trying to get this done quickly. Okay. Doesn't matter. Might be seen anyway. So Jehu Garcia did some assembling on my bigger modules, 8P modules, and they're meant for, you know, power applications, motorbikes, you know, ATVs, bikes, and they do not come with the self-fusing. So they wouldn't be that great. Let the cost alone, you know. Okay, let's do this mother. Okay, and the last one. You know, this step could be, you know, amended, because I've just put a tape So you, if cells fails, you can take them out, you know, easily and swap them for new ones. Right. Well, let's do this now. Let's see if it's gonna light up. Basically. There you go, 2 cells. 4 cells. It's a lot quicker than soldering. Six, and then we have 8, and then we have 10. Now they should equalize in capacity. Let's do this one. There we go. Let's check the voltages so we don't accidentally put the cell the wrong way. 416. 416. What's that? 416. 416. C7. Okay. I'll get some screws. Here. This is what I was talking about. Like a plastic inserts that are heat placed into the plastic. And there was ones that has a flange, so they're quite good, and they have a diagonal ribs, so they sort of have a good torque tolerance, you know, both ways, clockwise and anti-clockwise. And now I just need to get my bolts, but I can't remember where I put them. Okay, it's not here. It's not here. Gonna need some washers. Just in case. That should do it. And I'll just go and try to find my screws. That's weird. Here, but where did I put the other ones? Well, it's recording, that's fine. Let's check. Oh, yeah, that's fine. Okay, so I just came back from the shop and apparently we don't have any screws in M4 size. So I'm just gonna use whatever I have. So mix of screws and bolts. Okay, so now we're gonna get the our bus bar on, and that's gonna go like what? Like that. Okay. I'm just gonna grab a bit. And we just pop one in. On low torque. That's gonna be fine. I'll do it here. It should fit nicely. Okay, and then we're gonna put another one, which is gonna be here, and probably first we're gonna bridge those so the charge equalizes through, you know, bigger copper. rather than through a thin sheet of okay, let me get that one. And that. So the charge should transfer over from higher cells to lower cells, and they should be fine. And for the ghetto fuses, we're going to use some Ethernet cable wire. That'll work. There we go. That should be fine. Just unwind them somehow. Get them stripped or strip. Just a proof of concept, nothing more. It doesn't have to be sexy. I think I'm gonna strip it like that. Well, we'll see if it's gonna work or not. Just like that. Or maybe I'll go bit by bit. Just like that. Okay. I'll just put the thin ones, maybe 2 of them for each cell, because I haven't tested. Anyways, you should use proper fusing wire, rather than cable. That's gonna be fine. Just leave that here. Keep those if I need more. Right, so basically, I put a tab, a bus bar across here to equalize the cells, and it doesn't feel warm. They should. I probably should have left them for a longer period, but we don't have time for that. So I'll try. If the fuses will blow, they will blow. 403, 398, 410. Well, there's some difference, but hopefully it will hold. Okay, so this goes right here. I'm just gonna use some washers. Okay. Next one. I'm gonna make the files available so anyone who has a 3D printer can print their own. And I'm thinking maybe I will do the design where you can pause the printer, insert your nuts, and then print over, so they're encapsulated inside. So that should be okay. Now, I don't know if I should go single or double. Maybe double. Let's try double. Okay, so basically, I'm thinking you would just just put and twist around the cell. Just a bit fiddly. Right, where's my? Okay. Not ideal situation, but it'll do. It'll do for now. Missing one here. Okay. There's another one. So it's held by pressure, nothing more. Just like that. You can even use those, glass wire fuses. So it would be a lot easier to, work with them rather than very thin wire. Okay. Like that. And then get this one. what happens when you work with metal tools. Nothing to worry about. Okay, so wow. They do change color, so I guess there is some load transfer going. But you know, when you build a large speed group pack, you want your cells to be, you know, at the same state of charge level. What was that? That was something not great. Right, I think this next group is no, maybe not. I thought it's at a significantly lower state of charge level, so sort of a okay. It's just washers have a wee rip that just cuts the wire. So get it upside down. Forward. Personally, I wouldn't use wire. I would just buy a bunch of fuses. I know there are fuses like resistors. You just bolt them on. They have a, you know, thicker legs, so you can sort of manage them easier. This is just a bit, you know, not as sophisticated. Okay, and then we need one more for the last one. So that might be the one that goes. Let's see. Okay. That's too short. Get that one done. Okay, where's mine? Right. So we have finished what do you call 12 parallel cell power bank with fusing. There we go. Let's check voltage. If it's, then we have, and we have 4 volts. So now let's try and charge it and see if the fuses go, and at 1 amperage they will go. At what power? I have a high charger, so it can discharge, well, it can discharge at 20 watts basically. So we'll see if alright. And then we have what here? No. Just like that. Right. So we have a positive here, negative. Oops. No. That should be like that. Okay, I'll get the camera down here. Let's see. Okay. So you can see what's happening. I'm going to close up maybe first. This is our fuses. And they didn't require any soldering, so okay. Let's put it in a lithium program. And we'll change that. No, that's okay. Charge, and then we choose what power. So we're going to charge it at 20 amps, and so divide by 6. Let's try 20 amps. If it's gonna blow. 4 amps. Is that the cap? 4.2 amps. Oh no. Let's beat the button. Let's do 20. Yeah, 20 amps. So that will simulate if any of the fuses will blow. So just give me 1 second. That, and let's go. It's climbing. Yeah, that's caps at 17 amps. 17 amps. So that is 17 divided by 6. So it's 2.83 amps per slot, and it doesn't look like it will blow. Doesn't feel warm. Nothing. Okay. I'll stop that, and I will disconnect. couple of cells. Okay, and we're gonna try to push 20 amps through, what do you go, 1, 2, 3, 4 cells, 4 slots, 8 cells. Okay, checking battery, and it's climbing. 10 amps, 11.10 amps. That's weird. Oh, that one. That one went. Now it's 9.3 amps through 3 slots. 3 amps doesn't draw 3 amps. Okay. How can we push more so it doesn't? Let's try and do a special modes, motor drive, foam cutter. Motor drive. Okay, motor drive. Motor drive at what? What can we do? Can we do 20 amps? Let's check that out. Oh, yes. We do 20 amps and then 4.2 amps, 4.2 volts. Like that. Let's see what happens. Connection breakdown. So I suppose it can't. Let's try foam cutter. And then I'm going to do 4.20. Okay. Connection breakdown. Okay, so I can't fool this charger. But what can we do? We can go ghetto. And we can just short it. Right? That's a possible situation. I'll just grab a wire. Okay. Grab some thicker wire and just gonna connect those back up. Okay. Okay. Connect those back up. Probably would use a single core, rather rather than this type of nonsense. Right. Let's just see. Just gonna short it out. Okay. Ready? That's it. And those are blown. So in the end, you know, if the fuses are sized correctly, it should work. And the only thing that the cells should be chosen, so you know, they're at least 2 cells are closely matched per 1 slot. So that's the idea, basically. I haven't decided yet about the tabs, but it probably will be made for 6 slots. So you know, you jump to the next one and so forth. To make up a full P group. Right. Okay. It's really it's a simple design. All the time I try to make something, I want to make it as simple as possible. So, you know, the simpler it is, the less things to go wrong. I hope it transfers, you know, this video, you know, the concept. It's just rough example or display of the idea behind this, because I've done some soldering, I've done some spot welding, and that stuff is time consuming. You know, when you spot weld or solder the used cells, you know, which I like, you know, to reuse laptop, tool, battery cells for basically power banks, you know, the power wall stuff. It's pain, you know, when you have a large, like maybe 100 cell group, you know, all soldered up, and because of one cell, you know, you have to redo the whole thing. And this design, you know, it's modular, you know, you do whatever you want to some extent. So maybe 10 cells, so 20 cells, maybe 50 cells, 100 cells, you know, and then you would just, it has a wee dovetail, you know, type of connection, just basically for alignment, and then you would bolt, you know, to a piece of you know, aluminum or wood board. Aluminum probably would be better, you know, it would act as a heat sink for cells if they get hot, and and then you know you have fuse blown, so indicates that some cells are bad. You just, that's where this Captain tape comes in handy, you know. You just pull it out, take new cells, and then you just load them up, you know, and you're good to go. Simple as that. Very fast. And you don't ruin your bank. So that's basic concept, you know, of a power wall I would like to do. You can check my website at 18650.lt for my, you know, these modules. And the design is the same. The only thing is these ones cells are inserted from the top, and that is because I want to constrain them inside the box so they don't fly around. Just about this. Go. So, and it would be quite complicated to do injection molding, and it would cost me, you know, a fortune, because one mold will probably set me back at about 5,000. You know, when you have eight module sizes. You know, that grows, and that needs to generate, you know, a lot of income to cover that. And that's why 3D printing is a good alternative. You know, you don't need such modules for low power systems, because it's overkill. I've tested it at 200 amps. So, you know, even these, you know, with the correct fusing and probably new power cells would put out, you know, a lot of power for, you know, power wall as well. And the design actually came, you know, I've spent probably about 3 years designing it. And I just have some of my first prototypes, you know, made out of a FR4 flame resistant board, and originally I was gonna do 14S complete, you know, battery sets for electric bikes, but then, you know, one day, and this is another one prototype as well. That's a 10S. And then one day, just the Eureka moment came, and, you know, I've decided that modules like that would be more versatile, so people can use, you know, different voltages and stuff. And that's how it came to be. And, you know, I've looked at a lot of folks build, you know, power walls, solder cells, spot weld cells, you know, and then basically, you know, spend a lot of time of building it. And as you know, soldering isn't ideal because it heats up, you know, cell itself. Not so much on the positive side, where it heats electrolyte in the negative side, which has a negative effect on a cell. So basically, this approach would completely eliminate that, you know, undesirable effect on the cell. And if I can make them, you know, affordable, I think that would be a great solution. But I wouldn't know. So if you guys would like to leave a comment or send me an email regarding this design at info@18650.lt, I would appreciate it. And we can take it from here and maybe do something great. So cheers for that. Cheers for staying with me and watching this boring video with no explosions, no fires. I'll hope to make a video sometime soon, maybe a bit better prepared with the screws and stuff. And I'll see you later.